All right, sixth grade. So what we're doing today is we're talking about adding and subtracting mixed numbers with regrouping, and that's just a mouthful. But really the premise or the idea that we're getting at makes a whole lot of sense if we understand fractions. So if we can visualize fractions, if we can understand them, then it's going to be fine. It's really similar to adding and subtracting mixed numbers, but these are just some special cases where the way that our fraction pieces add up or we try and subtract them, it's not working out or it's not looking as obvious. So we need to do a little manipulation or change things around a little bit. So get that name, date, title, and these notes. When adding fractions, we sometimes create new whole units. So the idea there is, if I say you have 2 and 3/4 and you add 6 and 3/4, well, you got a whole lot of fourths. Now you have 6/4. And we know that if you have 6/4, you can make 4/4 or another whole unit. So this is the idea of when we kind of add mixed numbers and we get an improper fraction, we have to regroup it because we get another whole unit. The second note says that when subtracting fractions, we sometimes do not have enough pieces to take away. So if I say you have 2 and 1/3 and you're trying to subtract 5 and 2/3, well, you only have 1/3 to take away. How are you going to take away 2/3? And the idea is, well, you're just going to have to cut up one of those full units you already have, and we're going to try and visualize that in a second. But the most important note is this last part. In both cases, we can regroup with a mixed number. And how are you going to do that? What do you need to know about that? It's, well, one whole unit or a whole number, each one of those big whole numbers on the side is equal to a full set of pieces. What is a full set of pieces, Mr. Schwartz? A full set of pieces means that if you have 2 and 1/6, well, each one of those two full units is 6/6. It's all 6 pieces. So this would be the same as 1 and 6/6. So you can see that we took one of those two whole units and split up into 6/6, and we also had that 1/6 that we already had. So this is the same as 1 and 7/6. And that's the idea, it's just that we can trade in a full unit and get a full set of pieces, whatever the set is made of. Remember, our denominator tells us the number of pieces in one full group. So those are the notes you need, and let's see what it looks like if we try and visualize it. I tried to draw an example right here, and this is, hopefully if you can follow along with me and see this, I would like to say that this kind of looks like 1 and 1/2, 1.5 bars, and we're subtracting, you can see. We're trying to subtract 3/4. And you may say to yourself, well, I know that before we can subtract, we need like denominators. And that's right. So this is another visual of why we need like denominators, is because we can't take away fourths if we have halves. We need to take away same size pieces. So how are we going to do this? Well, we can split this into fourths. And again, I didn't add or subtract any shading. We just renamed this as 1 and 2/4. And that's fine. But even now, we only have 2 of these fourths, and we can't take away 3. So what are we going to do? And this is the crux, this is the whole idea, is we're going to trade in that full unit right over here, and we're going to get 4/4 from it. So I'm going to trade this in, and I'm going to create now an improper fraction. So this would be how many fourths? Well, we have, from the full unit, we got 1, 2, 3, 4. We got a full set 4/4, but we already had 2, so we have a total of 6/4. And that's the way we'll rename this. And we got to erase to show that we don't have all this on one side. Now we just have 6/4. And now if you have 6/4, you can take away 3/4. So if I'm going to take these away, what would it look like? We'll take away 1, 2, 3. It would leave me with 3/4. And we can see that just like when we subtract fractions like normal. We subtract the numerators, we get 3, and the denominator stays the same. It tells us the size of the pieces. So hopefully this visual helps us to understand it. Let's see what it looks like in some practice problems, maybe where we won't be drawing it, but we are having to use our mental understanding or try and picture it in our heads. So this says 7 and 5/6 plus 11 and 5/8. Now what we want to do first is, of course, like always, we need like denominators before we can add. So I'll rename this and I'll say, what do 6 and 8 both go into? Well, a multiple of both is 48, but the least common denominator, the smallest number we can use that they both go into, is actually 24. How many times does 6 go into 24? Well, to create an equivalent fraction, if we multiply the bottom times 4, we need to multiply the top times 4. We'll have 7 and 20/24ths plus 11, and we're going to want this to be out of 24ths again so we can combine same size pieces. If we multiplied 8 times 3, we also need to multiply the numerator 5 times 3 as well, and we would get 15. Now we can say how many whole units will we have? Well, 7 and 11 would give us 18 whole units, and 15 and 20 would be a total of 35/24ths. That looks awful. Can't help it. Gotta fix it. 35/24ths. Now, hopefully you're realizing like some blinkers are going off in your head. Like, hey, that doesn't make sense to call it 18 and 35/24ths. 35/24ths is an improper fraction. And it is improper because we have enough to make another whole unit. How many pieces make up another whole unit? 24. So if we trade in 24 pieces, 24/24ths, we'll get another whole, and we'll have 19. But if we use 24 of our 35, how many do we have left? We would have 11 left. So we still have 11/24ths, but we traded in 24 of our 35 to get another whole unit. So make sure that makes sense to you. That's the work I would like you to show me that you go from 18 and 35/24ths to 19 and 11/24ths. That could be enough, but if you want to show this little subtraction on the 5, or subtraction on the side to show how many pieces you have left after you regroup, that works too. Let's get to another practice problem, and maybe a word problem this time. It says Duck has listened to the SNSD album 5 2/3 times. If Mr. S has listened to the same album 7.5 times more, or 7.5 times, how many more times has Mr. Schwartz listened to it? Okay. So you know that I've listened to more. Sorry, Duck. I just got more years on Earth, so that's probably the reason. But how are we going to find the difference, or how many more times I've listened? Well, we need to subtract my amount minus Duck's. So we know my amount is 7.5, and half is 1/2. And we're going to subtract however many times Duck has listened to it, which is 5 2/3. Now, of course, like always, we need like denominators before we can subtract. So we'll say 2 and 3 both go into 6. To get 6, I multiply numerator and denominator of 1/2 times 3, and it gives me 3/6. That looks like a half, written as a different equivalent fraction. We'll take away 5 2/3, but 5 2/3 rewritten as an equivalent fraction with 6th will be 4/6 because we multiplied 3 times 2, so we need to multiply the numerator by 2 as well. Now, hopefully you're seeing the problem. A lot of people, and I'm going to send flashlights off again in your head, is a lot of people will say, oh, we're subtracting 4 and 3, that's 1. But that's when people don't pay attention to the order of our subtraction. We're trying to take away 4 from 3. We don't have 4 to take away. So what can we do? Well, this is what we tried to show earlier. I don't have enough 6ths, but I do have a whole unit that I can trade in. If I trade in one of the 6, or one of my whole units, I just have 6 whole units left. I traded in the 7th. And what did it get me? One whole unit is equal to a full set of 6 6ths. So I just earned myself 6 6ths. I already had 3. That's a total of 9 6ths. And now we'll subtract 5 and 4/6. And this looks like something we can do. I can take 4/6 from 9/6. We'll have 5/6. Remember that denominator just tells the size of the pieces. And 6 minus 5 is 1. I've listened to the album 1 and 5/6 times more. So there you go. Hopefully this regrouping makes sense. Again, the whole idea is that if we have a full set of a fraction, if we have 6 6 or 9 9ths or 5 5ths, whatever it is, we can either create a new unit, or we can trade in one of the units we already have, one of the whole numbers we already have, to get that many pieces. So there you go. I'm going to leave you with some problems, and here they are. The first one says 13 and 2/7 minus 4 and 2/3. So you're going to have to do that one for me. Well, and this is a typo, but it says if Yukari ran 2 4/5 miles on Tuesday and 1.5 miles on Thursday, how many miles did she run total? How many miles did she run total on those 2 days? Get to work on those. I'll see you tomorrow.